All right, guys, let's get this practice thing knocked out. Let's practice test for test 24. First one, prove all numbers 1, 2, 3, all the way to n is n times n plus 1 over 2. So remember, first step is always check it for 1. So I'm going to plug 1 in up here. 1 times 1 plus 1 over 2, which would be 1 times 2 over 2, which is 1. Check mark. It works fine. The check mark didn't show up there. Okay, now to do the actual proof, I'm going to go with 1 plus 2 plus 3 plus dot, dot, dot. And now the next term is going to be n plus 1. Remember, the next term is always you replace the n with an n plus 1. If you add it to the left side, you got to add it to the right-hand side. And once I do that, I'm going to take that right-hand side. Remember, I want that n to become an n plus 1 and that n to become an n plus 1. So first of all, see there's a fraction. So I'm going to go ahead and put everything over the 2 like that. And then I notice I have n plus 1s everywhere. I have an n plus 1 on both the first term and the second term, so I'm going to factor out the n plus 1. And what that leaves me with is an n and a 2 on the top over 2. Now, there's really nothing else I can do. I'm trying to make it look like this, except I want the n plus 1 where the n's are. So luckily, I already have the n plus 1 in the front, which is awesome. I'm going to take that n plus 2 and rewrite it like this, n plus 1 plus 1. And as long as that checks out, if this is exactly the same thing as that, then I'm in good shape because I want it to be just like this with the n plus 1s, which it is. So guys, put a check. That's it. Number 1. Let's go number 2. Move this up a little bit. Give us some room. Number 2, check the 1 first. So I'm going to plug in 1 right here. 1 times 3 times 1 minus 1 all over 2. That's going to be 1 times 2 over 2, which is 1, which is the first term. That checks out. Now let's see if we can get the rest of it. 1 plus 4 plus 7 plus dot, dot, plus 3n minus 2. Plus, remember the next term, you plug in n plus 1 where the n was. And that's going to, if I add it to the left-hand side, obviously I got to add it to the right-hand side, which I'm doing right now. Okay, now, remember where I'm going with this. I'm trying to make the right-hand side look like this if I'm circling up there, except I need both ends to be n plus 1. So I'm going to do 2 things at once here. I'm going to make everything over 2. I'm also going to distribute this first n, make it 3n squared minus n. Second parentheses, I'm going to work out what's inside there. I got to put a 2 in the front because I'm putting it over the 2. I'm going to get 3n. 3n plus 3 minus 2 is 3n plus 1. I'm just going to work on this side here. I'm going to 3n squared minus n. Let's distribute the 2. And I can combine the ends in the middle. And then I can go slide, divide, slide. Just for time's sake, I'm going to do slide, divide, slide in my head here. I'm going to get, let's see, I'm going to get a plus 2 there and a plus 1 there. Now, always keep looking back. Think about what I want to end up with. I want to end up with an n plus 1 in the front, which I already have the n plus 1, so I like that. That's going to be over 2. Now, I'm going to try to write this first parentheses of 3n plus 2 like it is up here with the minus 1. So I'm going to write 3n plus 1 minus 1. Now, I'm good as long as this second parentheses equals the same thing as that first parentheses does, which 3n plus 3 minus, it does. I'm good to go. That's the proof. All right, another one. Plug the 1 in again. I did give me 1 squared times 1 plus 1 squared over 4. Which should be 1 times 4 over 4, which is 1 cubed, which is exactly what we have here. So, see if we can do the big thing here. 1 cubed plus 2 cubed plus 3 cubed plus n cubed plus n plus 1 cubed, that's the key, equals this side over here. And, of course, we're going to add the n plus 1 cubed on this side. All right, now my advice when you start getting working the cubes, we haven't done cubic things too much, so I'm going to try to avoid doing cubes when I can. So I'm not sure what happened there. So I'm going to go n squared and n plus. I'm going to leave that alone for a second. I'll put it all over 4 like I do a lot of times. Make this 4 times n plus 1 cubed. Now I like this a lot. Both terms have n plus 1s. And think about this. I want there to be an n plus 1 squared at the beginning. So I'm going to take out the n plus 1 squared from both terms. What that leaves me with then is an n squared plus 4 and another n plus 1. So I've already got part of my final answer there, all over 4. Let's see, I'm going to work out the inside part of this thing. So it's going to be n squared plus 4n plus 4 all over 4. Factor that, n plus 1 squared, that's going to be n plus 2 squared over 4. Now, remember, this is what I need there. I need it to be n plus 1 squared and then n plus 1 squared. Well, luckily, 2 just happens to be n plus 1 squared all over 4. And because this parentheses is exactly the same as that one, and it replaces the n's with n plus 1s, we're done. All right, one more of them. Number 4. Try to make this go away. It's not cooperating. Sorry about this. This is great video time right here. It's just not wanting to go away, so I guess I'll do it the old-fashioned way. There we go. Okay, sorry about that. Number 4. Show that that is divisible by 5. Okay, so what I'm going to do first, I'm just going to set it up. Oh, got to show for 1 first. I'll plug in 1. 6 to first plus 4 is 10. 10 is divisible by 5, so we're good. Do the proof here. So I got 6 to the n plus 4 has to equal 5k. Means it is anything 5 times anything means it's divisible by 5. So somehow I got to get that to be 6 to the n plus 1 though. So first step I'm going to do is move the 4 to the other side like that. Then because I want it to be 6 to the n plus 1, I'm going to multiply that times 6. Because when you multiply, and if I do one side, I go to the other. But if I multiply to the same base, you add the exponents. So if I add those exponents, I get 6 to the n plus 1. Over here, I've got 30k minus 24. But I need this. I need the 6 to the n plus 4. So I'm going to put the plus 4 back here, which means I also got to put it on this side over here, which gives me 6 to the n plus 1 plus 4 equals 30k minus 20, which means I can rewrite the right-hand side. I can factor out a 5, which is important. Let's leave 6k minus 4. And I don't really care what's in the parentheses. The main thing is I got a 5 out there. If you can multiply something by 5 and get the other side, that means that side's divisible by 5. That's the proof. That 5 is the key. That 5 is the key. All right, number 5. Graph and tell the asymptotes. Let's start out by going, let's factor the top, because we can. Okay, the vertical, whatever makes the bottom 0, which is x equals 2. The horizontal, in this case, it's leading over leading. The x-intercept, whatever makes the numerator 0, which would be 1. The y-intercept, put zeros in for x's or cover your x's, that leaves you with 3 halves. I'm going to draw that real quick. My vertical is x equals 2. My horizontal is y equals 3. X-intercept is positive 1. Y-intercept is 3 halves, which is there. So I don't know for sure. I know one curve is doing this. I'm going to take my calculator, punch it in, see what happens on the other side. It's a curve up here. And that's it. Number 6, find all the zeros. First of all, I'm going to make a list real quick. Factors of 9 over factors of 2 would be 1, 3, 9. 1 half, 3 halves, 9 halves. I'm going to punch this in my calculator and see what works. And it looks like 3 halves works. I mean, negative 3 halves works. So 1, 2, negative 8, 9, and negative 9. Let's see what happens here. Bring the 2 down. The 2's cancel. It's negative. Okay, again, this is live video. I looked at the wrong function of my calculator. 3 halves does not work. 3 is what works. I noticed about halfway through, I was like, wait, that's not going to work. So I'm going to try the 3 instead, which hopefully will be better. 3 times 2 is 6. That's negative 2. Multiply, that's 3. Yes, that's much, much better. Which leaves me with this, 2x squared minus 2x plus 3. I have to solve that. I don't like the chances of factoring now, so I'm just going to do quadratic, your favorite. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And that's going to leave me with x is 2 plus or minus the radical is going to become 4. Let's see, 4 minus 24, negative 20 over 4, which gives me 2 plus or minus 2i on 5 over 4. Man, this keeps on going. So I get 2 plus or minus, sorry, I'm taking a 2 out of everything, which is going to give me a 1 plus or minus I on 5 over 4. And don't forget the 3 we started with. There's your zeros. All there is to it. You know, like, right. That's all there is to it. So, yeah. Let me erase this so I have room for number 7 down here. All right, number 7, if 10,000 is invested at an interest rate of 5% per year, compounded quarterly, how much after 6 years? This is straight up. This is the formula in case you need it, which hopefully you know by now. So principal is 10,000. 1 plus the interest rate is 5%. Quarterly is 4 times. And then my exponent is 4 times 6, which is 24. So just going to punch that in. And it's looking like $13,473.51. I'm going to punch it in, make sure you got the same thing I got, because you should. Last 3. Number 8, this is asking you 2 to what power is 1 over 32. Now, 2 to the 5th power is 32, but because it's 1 over 32, it's been flipped. That means it's got to be a -5. That's all you do there. Number 9, suppose you another interest problem. So it's 4,000 in an account that pays 4% per year compounded quarterly. How long will it take for it to double? Well, if it doubles, you're going to end up with 8,000. You're starting with 4,000. 1 plus 0.04 over 4, and it's going to be 4t power nt. So let's start out by dividing both sides by 4,000, which gives me 2. And also at the same time, let's punch in what's in the parentheses here. And when I work out what's in the parentheses, I'm getting 1.01 to the 4t. When you get there, because you need the exponent, you don't know it. Whenever that's the case, you need to do log both sides. So I'm going to do log of this side. When I do log of the right side, the exponent goes in the front, like that. To get my t, I'm going to divide everything. I'm going to do natural log 2 divided by 4 natural log 1.01, everything but the t. And when you punch it in, I would do this on the bottom. I definitely put parentheses around there just to double check, make sure everything's good. And punch in 4 natural log 1.01, close on that one. I'm getting 17.4 years for it to double. Quite a long time. All right. Last one, number 10, finally. Factor this thing. I'm going to go e to the x minus 4 and e to the x plus 3, because -4 times 3 is -12, and it gives me -1 in the middle, which means e to the x is 4 and e to the x is -3. Now, okay, and to get the x, I'm going to do natural log both sides. I'm going to do x natural log e equals natural log 4. Don't forget when you see natural log e, this is gone. So I'm going to punch in natural log 4 and get 1.3863. Now this side, I'm going to do natural log e and do natural log -3. Hopefully you remember, that's gone, that you cannot do natural log of -3. No negative logs, in case you're done. And that's it. We'll see you tomorrow.
I was looking at
Island and Carly and Abby just walked in case you're wondering.
Hi guys,
Hello,
I'm Abby,
everyone.
and I'm Mr. Brown's favorite. Bye.
I hope you enjoy your video. Yay!